Hi, I am Imal Aswath. Now I am going to teach for 12th standard. The chapter is sets. Check whether the relation are defined in the set A. That is, the set is A 1, 2, 3, 4, 5, 6. The 6 elements. As the relation is set of all x, y such that y is divisible by x, is reflexive, symmetric and transitive. Here you have to check, that is, whether it is reflexive, symmetric or transitive. So to verify it is reflexive, what you have to take, that is any element, that is x. Here it is given, therefore I take it as x belongs to A. X belongs to A. If x comma x belongs to A, then this this relation is reflexive. Then x comma x belongs to A, then we have to say that it is reflexive. In the same way, to prove symmetric, it is, we have to take x comma y belongs to R. X comma y belongs to R. X comma y belongs to R. We have to say that y comma x belongs to R. Then R is symmetric. Here in this question, we are going to show that is R only reflexive, symmetric and transitive. So next, transitive, to show transitive, we have to take any element, that is x comma y belongs to R and y comma z belongs to R. We have to prove, that is, to prove, what we have to prove is x comma z belongs to R. So first we have to take the set as A 1, 2, 3, 4, 5, 6. First we are going to check, that is, whether it is reflexive. So A is reflexive. So R is reflexive. So to reflexive, we have to take x. X belongs to A. That is, we have to take the small set, small element, single element. That is, we take this x belongs to A. To prove x comma x. So every element is divisible by itself. Therefore, every element. What is the relation? The relation is x comma y. That is, y is divisible by x. So here, if I take 1 comma 1, 1 comma 2, 1 comma 1, then 2 comma 2, 3 comma 3. So here every element is divisible by itself. But the 0 only, it is not, except the case the 0. But here in this set A, here it is not included 0. Therefore, R is reflexive. Next, what we are going to show is x comma y belongs to R. X comma y belongs to R. To prove y comma x belongs to R. That is to prove. To prove this, I have to take any two elements. That is 2 comma 4 belongs to R. Here 4 is divisible by 2. But here if I take 4 comma 2, what will happen? Here 2 is not divisible by 4. So here it is not transitive. So not symmetric, because x comma y belongs to R. That is 2 comma 4 belongs to R. But 4 comma 2 doesn't belongs to R. Therefore, it is not symmetric. Then next we are going to show that it is transitive. To prove transitive, x comma y belongs to R. Which implies y is divisible by x. So what is y by x equal to k1? I take it as some constant. Therefore that one as 1. Then y comma z belongs to R. That is y is divisible by z. Therefore z is divisible by y. Because here this one only come first. So z is divisible by y. Therefore z by y equal to k2. So now I multiply. That is, if I take this y by x and y by x and z by y, what you get is, that is y term cancelled. So I take it as multiplying 1 and 2, y by x into z by y equal to k1 into k2. Here y get cancelled, that is z by x equal to some constant that I take it as k3. Therefore now we can say that x comma z also belongs to R because z is divisible by x. Z is divisible by x. Therefore it is transitive. Therefore the relation R is transitive. Therefore if it is a equivalence relation, when we can say that it is a equivalence relation, it is reflexive, symmetric, transitive. But in this relation it is not symmetric. Therefore it is not an equivalence relation. It is not an equivalence relation.